These days, the range of tools and materials available to us as makers is expanding like never before. From engineering-grade composites to CNCs, lasers, and more. And with the rise of combination machines, it's all more accessible and practical than ever, even in a home or a personal workshop. But what new capabilities do these types of consumer-grade machines actually enable? Well, in this video, we're going to find out with a build unlike anything I've taken on before. A set of fully custom Bluetooth speakers that combine a very much 3D printing native ecosystem, Multiboard, with a handful of mediums and processes that are completely new to me, and probably to most of you. So, let's get after it. For this build, we're going to be using the Snapmaker Artisan, which is a 3-in-1 beast of a machine that can be converted from an enclosed 400 by 400 by 400 3D printer into a CNC machine or a laser in literally seconds. Snapmaker also sent over all the fixins from their rotary module to the air filter, both a fiber-like and a blue diode laser, an air assist pump, and even consumables. Full disclosure, they also did sponsor this video, but besides telling me both directly and on the machine itself to make something wonderful and checking the video for any factual errors, they've had no creative or editorial control over the video or what I say. I'll be showing you what the Artisan is capable of throughout the video, so if by the end of the video you're interested in checking out the Snapmaker Artisan or their full line of 3D printers, lasers, or 3-in-1 machines, I'll leave a link in the description. Oh, and while we're in the commercial type stuff, I do just want to let you guys know that I am probably going to be retiring 2 of our original merch designs, including this one, because I've actually got some other really exciting designs coming up very, very soon. So if you want one of these 2 shirts, and you haven't picked them up yet, now's the time. Let's go ahead and get into the project. And I have to admit that when Snapmaker first reached out, I really racked my brain and struggled to find the ideal project that I actually wanted to work on. Personally, I've never really worked with a CNC machine before, and because 3D printing is so thoroughly in my comfort zone, I feel like my creativity tends to stay within those bounds. Fortunately, it was at this point that a video popped up in my feed from a lesser-known YouTube channel called Pisces Printing. Over there, a guy named Justin creates these incredibly awesome custom 3D printed speaker designs based on his treasure trove of knowledge about acoustics, response curves, tension peaks, and a bunch of other stuff that I literally didn't even know was a thing. But I was intrigued. I love the idea of using 3D printing to create better, cheaper, and more personalized alternatives to expensive store-bought products that I actually need. And since I don't have any speakers yet in my studio, I did decide to just reach out to Justin and see if he was willing to do a cross-channel 2-video type collab. I'd provide the publicity and plenty of mentoring on the YouTube game and the process of video creation, and he'd provide the technical knowledge, the experience, the design, really everything. Actually, we had initially agreed that I would do all the external design and CAD work, but once we got on a Zoom call to strategize, I think it became abundantly clear to both of us that that wasn't a great idea. So let's start off by talking about the actual audio equipment and the speakers. Because of everything going on where I live right now, shipping is even more expensive and slow than normal, and so ordering from the kinds of typical American or European suppliers, even Amazon, just really wasn't an option. Plus, we both agreed that it might be a fun challenge for Justin to take some incredibly cheap, generic AliExpress components and see if he can actually design a speaker that produces great sound from them. So with that, we scoured the depths of AliExpress, as I'm wont to do, and came up with a list of components that seemed acceptable. We chose these 3-inch speaker drivers for $37 a pair, these tweeters at a suspiciously cheap $6 a pair, these 400-watt frequency dividers, which are basically the electronics needed for the inside of the speakers, at just $10 each, and then this Bluetooth digital audio amplifier for $20, plus some speaker wire I had lying around. So total cost, $82.47, plus whatever materials we use for the housings themselves. Which brings us to the design considerations. Take, for example, mounting the speakers. Recently, I covered, well, basically every vertical surface in my studio with either multiboard or honeycomb storage wall. It was at this point that I realized that multiboard is much more than just a pegboard alternative for your wall. It's an entire ecosystem or system of ecosystems, including, for example, multi-bins, which are these versatile, modular, and customizable bins. Now, not only do those have a wide variety of ways to mount onto multiboard in ways that are easy to adjust and remove, but they also have their own rails, which means that you can mount things to the bins themselves. Now, this means that I could not only, say, expand the speaker if I wanted to add an external subwoofer in the future, but it also means that I don't need to lose the entire area where I mount the speakers as dead space on my multiboards. With a little bit of luck, I can actually use the speaker housings themselves as real estate for mounting tools, displaying cool 3D prints, and so on. Also, because I have multiboard all across my office, or even at home pretty soon, I could at least ostensibly unhook the speakers from my desk and move them to another spot in the studio, or bring them home if I decide to rearrange my furniture or if I want to use them somewhere else. So pretty quickly, for all these reasons, I was sold on the idea of using multiboard to house a speaker, and we were off to the races. The first step was to reach out to Jonathan over at Keep Making. You see, for the best sound response and to prevent the material from flexing, we ideally wanted at least 3mm thick walls. And sure, we could easily have used the standard 3x4x3 multi-bin as is and then laser cut some extra material on the inside to reinforce it, but we also did want to create a version that didn't have all of the holes on the side walls. Yes, you could do this and remix it yourself, but fortunately Jonathan was kind enough to quickly whip up a remix with thicker, unperforated walls because I really suck at Blender. From that point, Justin took over the CAD and design work, testing and paying careful attention to the speaker's acoustic performance. Actually, he is releasing a companion video to this one all about his design process, the technical parameters, testing the drivers, and how they actually perform on a technical and expert level. So I do highly recommend that you check that video out, which is linked below, to learn what goes into something like this. Believe it or not, it actually doesn't seem that hard to learn, and he did share with me a bunch of incredibly powerful tools that he uses to do all that kind of complex mathematics and simulations for him. So if you're interested in acoustics or just building your own pair of 3D printed speakers, you will definitely want to subscribe to his channel. So now it's time to actually create these things. I started off with 3D printing the outer housings, and because we want the outer housings to be incredibly rigid, I chose some carbon fiber PLA. Now this obviously really limited my color choices. I might have preferred white to match the wall, but I'm thinking that the trade-off is going to be worth it. And on the note of carbon fiber, I was really surprised and really happy to see that despite using a pretty unique dual nozzle tool head with a quick swap heatsink, the Snapmaker, unlike, say, a Bamboo Lab, still uses commonly available M6 threaded nozzles, so I already had plenty of compatible hardened nozzles lying around. They weren't the same height, but it does also have an automatic utility for aligning each of the nozzles in X, Y, and Z, and you can also manually adjust the Z during printing, which those seasoned vets in the audience will definitely appreciate. Because this print was going to take such a long time at 0.16mm layer heights and solid infill, and because this filament had sat out for literally years at this point, I also made liberal use of this fancy Drywise inline filament dryer I have, which dries the filament as you print it. Printing the two housings out honestly went off without a hitch, so why don't we just move on to something a little more exciting. The next thing that I needed to print was the air channels, which direct air from the speaker outwards. Apparently, as I learned from Justin, these need to be a very precise size to get the maximum performance out of the speakers, and ideally, you want smooth, organic shapes to properly direct that airflow. And ideally, you want that without rough surfaces or marring inside. Fortunately, the Snapmaker Artisan, released in 2022, mind you, is the first printer I've ever had with a rapid switching dual extrusion toolhead. What? You thought that was something new and innovative? And after some successful initial tests, I decided to play around with this feature and see how it could improve the end result. At first, I tried some leftover Bamboo Lab support for PLA material that I've had lying on this shelf for ages, just as a basis for comparison. I've honestly always hated this stuff for a few reasons, but I figured that if I could save the more exotic stuff, then I should. The end results were okay, but as expected of some old material, they were very stringy, and I don't think I cleaned the build plate nearly well enough because the purge tower did tip over. Still, I was able to remove all this. Gotta run, guys, 1 second. We have a rocket siren.
A few moments later.
All right, where was I? Still, I was able to remove the supports both inside and out and get a clean part, even if removing the internal supports took at least 15 minutes. For the second version, I tried printing with Polymaker's PolyDissolve S1 PVA, which dissolves in water. There was a profile already available in Snapmaker's Luban software, though I think I probably should have tweaked it for the Polymaker brand, and I could have gotten better results. Now, this was the first time that I'd ever used dissolvable support material, and all I can say is it's weird and gummy and kind of disgusting. But here's how the removal process went.
Okay, it's been about 10-15 minutes. Let's see what we're working with here. Oh, that's really unpleasant to touch. Oh, that's gross. Feels very slimy and goopy, but it's mostly out. If I leave it in here, it'll, oh, look at that. Look at that. I was gonna say, I have no doubt that it'll all dissolve, but at this point, it's ready to just come out by itself. Ugh, that is so gross to touch. Just imagine if you had a handful of those Tide Pods or laundry things, which is the same plastic as these, and then you just let it melt in your hand. Ugh, I don't like the feeling of that, but I do like the end result.
So that's all the 3D printing for this project. Let's switch to some other mediums.
All right, I've procrastinated this long enough. It's now time to get to the part that I'm absolutely dreading, which is learning CAM and CNC. And converting this thing to a CNC machine. Should probably find the instructions. I'm not going to, but I probably should. All right, let's see. No, that's not so bad. Okay. Huh, look at that. That's at least connected. You ready to go? We got this quick swap plate. Let's see. All right, that was crazy quick. Look at that. Well, that wasn't so bad. Well, look at that. It says right on here, call it a nut. Easy enough. Let's take our flat end mill. Looks pretty neat. Okie dokie. Swaddle bowl. Yeah. Oh, that's pretty satisfying. Okay, at this point, I think it's clear I have no idea what I'm doing, but I did a little bit of thinking and a little bit of tinkering, and here's what I've come up with. Let me show you guys. So I'm clamping my work pieces with these things, hoping against hope that the CNC is not going to hit that. I don't really know how to prevent, but I've got an emergency stop button, so let's cross our fingers. Now let's run the boundary just to see that it's not going to hit anything. Yep. Yeah, you do you. Yeah, buddy. All right, here we go. I'm terrified, but let's just do this thing. It's cutting. Okay, that's enough time lapse. My ears hurt. Much better. All right, so the first cut went, honestly, a lot better than I could have imagined. But then I made a beginner's mistake, which is if you want to use the bit assistant, you shouldn't take the bit out and then it can help you calculate the offset and keep the position otherwise, so that you can do two different tools in the same exact position, if that makes sense. So now I'm gonna have to try and manually position things, and I don't think I'm gonna get it right, but worst case, we're learning and we can just cut it again. Let's see.
Okay, so besides a cold, I have also these reclaimed wood panels, which I took out of what I call free hardware stores, which is buildings that are set for demolition and remodeling here in Tel Aviv. But I just realized that they're in pretty bad shape, so I want to see if they're even worth using. I do like to use reclaimed materials that were destined for the landfill, if I can. And unfortunately, I don't have an orbital sander, so we're just going to do it with a multi-tool. This doesn't look half bad. I think with some sanding, maybe a new coat of varnish, this is totally savable. There's no need to use new wood. It's gonna be a little extra work though, but I like that this has a story. So let's use it. Well, damn, that took an eternity with a penknife. So I think I definitely next time should be less conservative and go deeper and not worry about hitting the spoil board. But also, it would be nice if Snapmaker added the ability to add tabs in Luban, though I think you can also use the CNC feature with other CAM software. So maybe I should just take the plunge and learn how to use one of those. All right, let's have a little test fit here. See how we're doing. Oh yeah, that's perfectly fine. Holy, don't need a better tolerance than that. Cool. Now let's see if we can make them look nice. Okay, so I want to try experimenting with something, which is instead of trying to CNC those fine details of the ring, what if I can laser cut the outside and then use the laser to etch inside and remove material so I get those cool pockets without cutting all the way through? I don't know if it's gonna work, but let's run a material test and experiment. I don't want to sound like a shill, but I'm really appreciating how super fast it is to just change this thing from one type of machine to another in like literally a few seconds, because it really helps if you're indecisive like I'm being right now and you're not sure which technology you want to use for which different part of your project. Pretty cool. Let's try some lasering. Well, this is pretty cool. I didn't think this thing had a camera, but apparently it can detect visible flames, and it seems to have put out whatever fire was going on in there with the air assist pump, because I don't see a fire, but good to know that it took care of it. All right, we are cutting. We've got all the fumes going in here and automatically being vented out the window. I'm not sure where in the process I rescaled the thing, but this doesn't seem right. All right, looks like the smoke has cleared. Oh, not quite, but I'm impatient. Let's see what we got. I guess in addition to figuring out which method I want, I should also figure out if I'm gonna use laser cutting, then how's the actual wood gonna look after varnishing? Is it gonna look as nice as the veneered plywood that I have? So let's test that out. All right, good news. I think I figured out why the cut wasn't all the way through last time. I thought the board was 8.3. It's actually 8.6, and I had already done a 0.5 millimeter allowance. So this time we're gonna do a new cut. We're gonna see if that works, and if it doesn't work, now that I know how to use the laser, we're going to just laser out the outline. Let's see what happens. Hey, we are back for another day. Had to head home because things got a little squirrely yesterday. So I'm having this problem where I'm able to line the laser up perfectly and get the cuts. But what's happening is because I need to cut lower than where I actually am, I need to focus the laser lower, and it's causing visible fires, which is shutting the laser down. Fortunately, I think I know where the marks are, so I'm gonna try to flip the workpiece over, line the laser up, and cut from the front, and really hope that I don't damage the workpiece. And then I should have a really, really clean cut without the fires coming. Let's try. By the way, if you're wondering why and how I'm operating a laser while my kids are here with me, I just want you guys to know that this thing not only will stop the laser if someone opens the door, but there's also a password that you need to run the laser. So it is safe to be operating this around the kids, especially with the air filter. So way to go, Snapmaker. It's looking pretty good. And this time, no fires. I think we're in good shape. We'll only know when we match it up to the speaker, but yeah, it cut through. And boy, are those lines cleaner than the one that I did with the penknife. Great. Does seem like I was off by 1 millimeter in either direction. Actually, it doesn't matter because there is a bit of play in here for clearances. And so we can just push it over to this side, and the edges should look just fine as long as it's pushed over. That edge will look fine, and that edge will look fine. All right, Philifam, we need to make some decisions. So I've got a bunch of different options laid out here, and I've just been kind of experimenting with all the different mediums and options that we have. So obviously we've got the black box, which I'm pretty set on, but we have different choices for the face plates and the little beauty plates. So here's one option that I think is really cool, which is this orange-esque faceplate with obviously the speakers in here and this. However, when I went to do the wooden grill laser cut, I really think this is quite ugly, this kind of look, and it doesn't have like all the nice curvature of the other one, and lasering out the pockets just didn't do the same job. I think overall the black on black is pretty hideous. It's just really boring. So I'm kind of settling on actually going with the reclaimed wood veneer version. Then I think honestly, out of all the options that I've played with and tested, I think the one that I like, believe it or not, is actually the crazy orange trim. Like that contrasts on the black and is actually a pretty close match to the wall. But I'd love to know what you guys think in the comments. Like, am I way off? I kind of really like this look. I don't know. But I can always change it too, because everything here is modular. Let's get them assembled. All right. That took an absolute eternity. It shouldn't have, but for some reason, I just could not get any solder with any soldering iron to stick to this speaker wire that I bought, and I have no idea why. If you know, let me know in the comments. I've now got everything wired up though, but before I go ahead and glue the actual faces to the speakers, I think we should power them on and see if they work. All right, the controller is on. Let's connect to it, see if we can play something. Okay, I hear something coming out of one tweeter. The rest of it doesn't work. Good thing we didn't glue it together, right?
The next day.
All right, guys, good news, even if it is a little bit embarrassing news. The issue is actually not my solders. I spent about an hour on the phone with Justin. Thank you, Justin. And we diagnosed everything. And in the end, it was just my crimps. I had crimped onto the wire sheath and it wasn't making proper contact. But now, check this out. Sounds amazing. Let's get this assembled and up on the wall and see what the speakers are going to look like. Obviously, I can't really convey to all of you at home how these speakers sound, but I'm impressed. And more importantly, I'm really happy with how they turned out. But I would love to hear in the comments below what you think. As for the Snapmaker Artisan, I gotta say, I'm really excited about having an easy-to-use laser and an easy-to-use CNC, both of which have such a large work area. Not to mention, this is currently my only enclosed nozzle or tool switching printer. At least until I finish this thing. Initially, when Snapmaker offered to send the Artisan over, they told me that I could get rid of it after the video if I didn't have enough space in my studio to keep it. But I'm gonna be real with you guys. This thing isn't going anywhere. And I'm really looking forward to using it in some upcoming projects. Finally, as for the speaker design, Justin is going to be publishing his files along with his video, so you can try printing them out yourself if you'd like. That's all for this week, but I'll see all of you on the next layer.